Okay, so this is going to be sort of an example video of what a good EvoBeaker presentation or research presentation in Bio 440 should look like. And this first one is not actually going to be the final product. It's going to show you some slides and some things that you should consider when you're putting together your final product. All right, so let's take a look at this. This is a good first slide. I mean, number one, it's simple. Everything here is going to be simply done. Okay, you're not going to have stupid backgrounds. That's like if I were to have, here it is, people put in stuff like this, or like that, or like that, like that. Don't. Okay, that doesn't add anything. Okay, none of that adds anything to your talk. So, how the hell do I undo this? Whoops. Okay, so don't do that. Okay, keep it very, very simple. I'll show you sort of how things will go. This is not a bad start. I have a nice title here: Generation Time, Mutations, and Fire Resistance. The selection influenced plant community dynamics. So it's not a simple title like plants or plant evolution. That doesn't tell you anything. You have to have a title that basically gives you some idea what your talk is going to be about. Okay? Evolution or EvoBeaker presentation. Not acceptable. Okay? So something like you would see a title for a scientific paper, something along those lines. Then I got my name down here in my institution. That's a pretty good start. But remember, the talks they're not just talks, but it's a visual story that you're telling. And you want to try to get the interest of the audience. You want the audience to look at your stuff. You don't want to make it noisy, but you want to make it visually appealing. So a good way to do that would be to replace this white background. And let me just say, a good, simple white background is going to be great. It's going to give you good contrast, so it'll be easy to read the text. It'll be good for putting your figures here because you're probably going to have figures from Excel. All right, simple background is what you want. But a way that you could improve some of the slides is to have like a nice little image in the background. Okay, so I think this is a nicer way to start, right? So it's got a fire, wow, fire, that's cool, but you can still see clearly my text because it contrasts nicely with the background. I bolded it here so it's a little bit thicker and stands out, but this is a really good way to start your talk, okay? All right, so, and then when you start off the talk, don't just read the title. That's dull and that's boring. I would start the talk something like, hey, good morning, my name is Mike Robinson, and what we're going to talk about today is fire in prairie communities and whether or not plants can evolve resistance to this fire and how that then will affect what happens in the community. Okay? Now, one thing I'm going to point out is I did use EvoBeaker for this, but I used a different module than you will have access to. So I use that simply to keep it so there's no real influence or direct influence on what you're doing, right? So I haven't done anything with finches or guppies or whatever it is you might have done. All right, so here's what you're gonna want. You want background, okay? Because you want several slides to introduce the background. You're gonna want some basic background about evolution. Now remember, you're not talking to children. Okay, you're not talking to your grandparents. You're talking to people that are somewhat, have some education in biology, have some education in science. There'll be some undergrads, obviously, and there'll be some faculty, okay? But you're not, so don't dumb it down too much, but there's no reason to go into tons and tons of jargon either. Okay, a good talk is going to appeal to a lot of people. So maybe think like you're giving a TED Talk. All right, if you know what a TED Talk is, that's a good thing to shoot for. So here's a little bit of background. So first I'm talking about selection, so I just want to make sure everyone knows what selection is all about. Now this here is too many words in my opinion. Now, you'll see some slides that have even more words than this. Ideally, you have as few words as possible on the slide because you want the audience to be looking at you, listening to you. You don't want the audience to be trying to read the slide while you're talking to the audience and your sounds coming out of your mouth are interfering with their ability to read, and it gets very confusing, it gets very annoying. Okay? So don't put any more text in the slide than you need to. So we can reduce some of this, right? So we can reduce it to something like this, some bullet points. So basically everything that I'm going to say this information, but oh, different. Oh, look at that. I forgot to finish this off. That's one thing you don't do. You can make sure you don't have mistakes in your PowerPoint. This isn't going to be my final slide anyway, but this should say differential survival among individuals related to phenotype, period. Okay, but so let's reduce the words anyway, all right? And so this is enough that it gives people a little bit to hang their head on, hang their hat on, I don't know what, hang something on, but they can still pay attention to you. So we get across that natural selection creates adaptation, and what does natural selection require? Requires heritable variation and differential survival. So that's a pretty good start. You give some nice background on what selection is. Looks a little boring, okay? Let's spruce it up a little. You know, you could put a few things. You could put more fire if you wanted, but we're talking about selection. So why don't we put Darwin, okay? And that looks pretty good, but it would be cooler if we can kind of get rid of this black and white contrast. So let's just make the whole slide black, and we'll make the text white, bring it all the way to the front. And now it kind of fits here next to Darwin's head. There's still space. Now, here's one of the things you're going to want. You want space in your slide. You want empty space, because too much space is going to create a problem. Or, sorry, if you fill it all up, it creates a problem for the human eye. So this is pretty good. I like it. Visually, I think this is rather appealing. Okay, so continuing with the background, you know, I want to start talking about my particular system. In this case, I'm talking about prairie plant communities. And so I got a picture here, some plant communities from the prairie. And I want to say that they're diverse, so I could have that little bit of text here at the bottom. But why do that? I could just have it look like this, and I could know what I'm supposed to say. So if you're not confident that you're going to know what to say, okay, go ahead and put some of the text on the slide. It's fine. It's not going to kill it. But if you know what you're going to say, so I want to say prairie plant communities are diverse. We have lots of different kinds of plants here, blah, 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 blah. I talk about all these different things. Then it's much nicer like this. Okay, so I'm just continuing with my introduction, and I'm going to talk about how fire affects the dynamics of communities at this point. So I have a slide here with fire going through a prairie, and I'm going to mention how fire will remove a lot of the older, more established, better competing species, and even though it's going to burn up the grasses and the shrubs, it'll leave room for them that wasn't there before, where they can grow. All right. Now, again, I can have all this text here if I want, but if I am confident, and this is how I would handle it, I would probably just have this image and just talk about the situation. Okay. Another way to approach it is if I do want to have the text that reminds me, right? So I can talk about how fire comes in and it removes a lot of these guys, but I could match it up with another slide. So I could say, instead, I could do it like this: how fire comes in and it's going to burn up a lot of these plants, and then see, I can shift to this next one and it includes the text that I want to say at this point. So it's going to remove a lot of these older, longer lived species, and then the younger ones or the faster growing ones will be able to come into the space where the longer lived ones used to exist. So anyway, that's a pretty good introduction. Got a lot of pictures, but I'm getting my points across. And then, so this is what I could do if I didn't want to include any of the text. And then I'm going to get to the meat of my particular research, right? I have to do this. I have to get to what is the question that I'm asking, or what is my hypothesis. So I'm going to talk about selection for fire resistance, right? So do they differ plants do differ in generation time, okay? And shorter lived plants, they have an equal number of mutations per generation, but because they're going to have more generations in a given period of time, they're going to have more mutations in a given period of time. So they're going to mutate faster. And then here's a little reference. I just made this reference up, but you do want to have a reference to some part of the scientific literature, not a textbook, okay? Something published in a journal somewhere. And then I get to what it is that I'm going to talk about. You have to include something like this. Right? This is the exact question that I'm going to address. Will selection for increased fire resistance in short generation shrubs affect community dynamics? Okay? So specify your particular question at some point. All right, again, I got a nice little background, but it's not overwhelming. And then the text is over here that has plenty of space and it contrasts well with the background. Okay, and then you're going to want to have some screen captures of EvoBeaker. Now, most of the people that are going to be here at the talks are familiar with EvoBeaker, but you still can't assume that. You're still going to want to talk about your particular study system, okay? As if you were talking about what you did in the wild. And so here's a little screen grab from EvoBeaker. Just have a bunch of white on the side. That's not really adding anything, and in fact, maybe distract. So let's make the background black. That'll look better when it's projected. Okay, so, and then I'm going to want to talk about it. So I'm going to say, okay, so EvoBeaker is a simulation, blah, blah, blah. But this is simulating a prairie where each of these represents an individual plant of some sort, either a grass or an annual plant, blackberry bushes, shrubs, okay, of 8 different kinds of plants. 4 grasses and shrubs, which are shorter lived, and 4 trees. Here, this represents the number of individuals of each group. So we have about 250 grasses, a little over 300 annuals, etc. Now, you have to walk people through your research. Now, you don't have to tell them every single thing about what's going on here. You want to tell them about what is important. So I'm not going to talk about the speed. That doesn't matter. I'm not going to talk about the control panel. That doesn't matter. Okay? But I'm going to talk about the things that are important for them to understand the study system and my particular question. Okay, and so then I'm going to walk them through what I did. So what I would do is I would run the simulation for a number of years, and the community dynamics would change so that over time, this diversity index here would change as the community became more or less diverse. A 1 would be the lowest possible. Okay. This down here, I can control the number of fires that happen per year. And I can control the chance of fire spreading. And I would record the diversity index over time. So here we see this is at year 20. If we run it to year 125, which is the maximum, we get a community dominated almost exclusively by hickory and oak, right? Almost exclusively hickory and oak, and there's a little bit of everything else. The diversity index is very low because it's almost only these 2 species. Now this is a setup with 0 fire. When you add more fire, it's going to become different. What I could do to simulate plants evolving, and I'm going to go through all this. You know, I shouldn't talk so much about this right now because I'm going to go through this as an example. But now I'm going to talk about how I controlled the system. And what I did was I chose to change the flammability, right? How likely a plant was to catch on fire of shrubs. And so I'll say I could set up this model and I would put that there and I would have this, and these are like little individual screen grabs that I would put up. And I could change the flammability of shrubs from 1, which is highly flammable, to 0.5, which has a flammability half of that, all the way down to 0. Okay, so I'm pointing out how I'm changing this system. All right, and then if I run it for 125 years, this is what I would get. Okay. So then I'm going to talk about the methods, and you don't have to. No, let me put it another way. It's good to have a summary of your methods like this. And I'm just going to say, so I set it so that there were 3 fires per year. I adjusted the flammability of the shrubs, like I said. All right. I picked shrubs out of all of these because of median generation times. And these are the flammability values that I use: 0, 0.25, 0.5, 0.75, and 1.0. So I'm explaining to the audience exactly what I did. What I didn't change, and I talk about the things that could be important. So competition, which is this transition matrix, settlement. Okay, I'll talk about more of this when I give this as an example. I did 5 runs for each of these. So 5 trials, 1, 2, 3, 4, 5. So a total of 25 trials. You definitely need to repeat your experiments multiple times. Not repeating your experiments is a total cheat. Okay? You must repeat your experiments multiple times. And then I said, and what I took in the end, this is the data that I collected, Simpson's Diversity Index. And then here I show my results. I don't write results up at the top because obviously it's results, right? We're not all morons. We can look at that and like, oh, here are the results. Okay, you don't need to tell us that. But you do need to have the axes properly labeled. So this is the diversity index, plus or minus 1 standard deviation. So the error bars are standard deviation. These are the means. Remember, we did 5 runs. So this is the average of 5 and the standard deviation. This is the year. So I can say I collected it every 25 years. Boom, boom, boom. Now, this is why having a white background is good, because I can copy this image straight out of Excel and paste it here. So I made the figure in Excel. I copied it and pasted it here as an image, and I cut out the border. And now it's nice. It fits right there on the slide. It's beautiful. It's a beautiful, beautiful slide. Okay, and then I'll talk about this, and then I talk about one thing you got to do is you got to walk people through your data. You can't just put it up there and expect them to know what they're looking at. So here I'm talking about the years. I collected every 25 years. This is the diversity index. Really, 1 is the lowest, so maybe I should have made that the bottom. I don't know. Okay, that might have been a mistake. But it's a minor one. And this... And what you can see is that the diversity index increases over time and then decreases once you get to around 100 years, and it sort of levels out right around 2. Okay? And then here's my next bit of results. This is looking at all 5 of the flammabilities for the different shrubs. Up here I have a little title that explains. It's not, I could put something generic like flammability in shrubs and community diversity, but why not put something that actually tells me what's going on? And because the low flammability tends to have higher diversity here at the end, right? So 0 is up there, 0.25 is there, 0.5 is there. So low flammability in shrubs increases community diversity. Boom, I put it right there. Again, walk the audience through the slide. So just you would kind of explain what each thing here is showing, okay, how to interpret it, what these over here are telling you, okay? And then you're going to want to have, how do I know that there's a difference? And you say you did an ANOVA, okay? An ANOVA is a statistical test. You should talk to me about what statistical tests you are going to want to run. Okay, but then I have this pop up. You see how this is there, and then it pops up because this way I can tell them all about this. Slide's not cluttered, and then I can go to my next thought, which is I did an ANOVA on these data, and it was significantly different. One thing you'll notice is I don't have tons and tons of those stupid animations or transitions. Okay, I have very simple. If something's gonna show up, it's gonna fade, and that's it. It doesn't come flying in from the left or flipping around or anything like that. And to go from one slide to the next, I get a fade. Okay, it's nice. It's not sliding all over the place or anything like that. So you can do a lot of good stuff with Excel, but for the most part, simple is better. Okay, and so then if I'm done my data, I'm going to have a conclusion slide. A little bit more text is okay. Again, trying to keep it simple. I tried to minimize the text here, but I thought what I had here was pretty good. And so basically, I came to a conclusion, right, that fire resistance would be good for the shrubs and it would increase community diversity. Why don't we see it in the real world? This might not be something that you have to worry about. In this particular case, it is, but you should have some sort of big question, something that addresses some big question, right? So just because you might be working on guppies doesn't mean that the only people who are going to care are guppy people, right? There are a lot of guppy people, but the majority of biologists are not guppy people. So you're trying to appeal to a much broader audience. So if you have a question on guppies, remember you're using guppies as a model to answer some bigger question. So you might be using guppies, but your question will be interesting to people who study zebra finches and maybe hogs and maybe crickets and maybe a whole bunch of different kinds of organisms, right? So you're going to want some big picture type of thing at the end. So here I'm talking about why don't we see this in the real world? So, and I give a few possibilities, but I can't answer any of these. I don't know. These are just sort of speculative, but as long as you don't pretend that you know, as long as you say these are possibilities, these are good, and it shows that you're thinking about your results. And then at the end, I have my literature cited. Again, nice little picture. I'm not going to spend any time on this. I'm just going to put the slide up there last after my conclusions and say thank you very much. And that's it. All right. Now, one thing you'll notice is here you can kind of see the text very good, very well. But if you want, you could kind of make a background and make it a little bit transparent. And you might be able to do this on other slides as well. You can do that. And this way you can still see the background a bit. Doesn't really interfere with it, but you can see the text much better. Okay, so that's kind of how you put some ideas anyway about putting a good talk together. I'm going to go and run through it as an example for how I would give this talk. And hopefully that will help you focus for your talks in evolution and for any other talk for that matter. All right, thank you.